This video covers assignment 3. Assignment 3 is the assignment where we generate the random numbers and put them into an array list of 3D points, or a point class, which is stored into an array list. And then we copy the values out of the array list into a two-dimensional array for later display. So the first thing we will want to cover is how to generate random numbers. You could always Google this up, and I believe I have some sample code out in the assignment files, but let's go ahead and cover it here. So I'm going to create a project using NetBeans. New project, Java application, assignment 3. I don't mind if it creates a main class. It's all well and good. Okie-doke. Next I'm going to delete the comments, just because when I'm showing the video, having too many comments eats up screen real estate. Okie-doke. Now let's generate some random numbers. To do this, we're going to use the random class. There are other ways to generate random numbers. I believe there's a random number method inside the math class, but this is a nice way to do it. So you need to use the random class, and we will create a random object. Why don't we just call the object R&D is equal to new random. All right, and it's telling me that there's no such thing as a random class. That's because I forgot to import. I'm going to go click on the little error, and it says cannot find class, add import for java.util.random. And as I've warned before, you don't want to just recklessly go in and always click that red arrow and choose one of the choices unless you know which one is correct. In this case, we do know. We do want to add an import for java.util.random. And there it goes, right underneath our package statement. Now when you generate a random number, when you instantiate a new random object, you can feed it a number. That number is called the seed. With the seed, it will generate the same series of numbers every time you run. Otherwise, they are much more random. In order for me to test the application, I would like to have a seed, but then I may remove that towards the end. So I'm just going to seed it with some number, and then I'm going to place that as an argument to the constructor. All right, now when we instantiate our random object, our R&D object, it will be seeded with the number 1, 2, 3, meaning that the numbers will be the same every time we use it. Let's prove that with a for loop or while loop or something like that. For int x is equal to 0, x is less than 10, x plus plus. Let's print out our random number, system.out.println, rnd.next int, and we want to generate numbers between 0 and 9. So I'm going to put a maximum of 10. That means from 0 to 9 because the 10 is not inclusive. All right, let's run it. And it's running the wrong application because I forgot to set which project we were working on. Right now it still thinks I'm working on assignment 2. So I'm going to kill that, come up here, go to assignment 3, right click, choose set as main project. You may not have to do this depending upon which version of NetBeans you installed, but if you ever find yourself running the wrong project, go ahead and check to see if you can do a set main project. All right, now assignment 3 is highlighted with bold type, and I'm going to close all the other windows just to prevent any confusion on my part or NetBeans. All right, now I'm left with the same code. I'm going to run it again. And here's our random numbers. 20695. Let's run it again. 20695. Sure enough, it's printing the same numbers. If I change this to a print rather than a print ln, then I'll get to see all the numbers on the same line. 206957. If we remove the seed, then when we run it, we'll get a different sequence of numbers each time because it is seeded with the system clock. So if you're making a game of some sorts, you don't want to give it a seed. But when you're testing an application, sometimes it's nice to see the same series of numbers come up over and over. Okay, so that is how to generate our random numbers. We instantiate an object of the random class, and then when we want a number, we call nextInt. We give it an upper boundary, and we have to remember that it goes from 0 up to 1 less than that boundary. So if we want to generate a number between 1 and 9, what do we really have to do? Since the random number starts at 0 and goes 1 less than the boundary you put, why don't we do it between 0 and 10 and add 1 to it? No, I don't think that's going to work. Between 0 and 9 and add 1 to it, because that'll generate a number between 1 and 9, because this boundary is exclusive, so that really will be a number between 0 and 8. And then we'll tack 1 onto it to get 1 through 9. So random int 9 plus 1. All right, let's print our 10 numbers between 9 and 1. 9639, I don't see any zeros. Let's change this to print out 20 of them. Looks good to me. We never get any zeros, so that's what we want. So that's our random number generator. We could move this into, a method. Move it into its own class, but we don't really have to. And we certainly don't need a loop, so I'm just going to comment this out for now. Now if we want to generate 3 values to store into a variable, like an x, y, and a z coordinate, we just do it like this. We're going to generate x, y, and z. And do x is equal to r&d.nextInt 9, 1, or 9 plus 1. Y is equal to r&d.nextInt. And z is equal to r&d.nextInt. Now I'm not going to run this to test it. I could, system.out.println, print 3 numbers. I'm going to use printf for formatted print. %d space %d space %d followed by a new line, and then I'm going to pass in x, y, and z as arguments to the formatted print to printf. And if I run this a few times, I should see 3 numbers: 963, 963. I'm getting the same numbers over and over because I am passing in a seed. Let's delete the seed. 735, 574. Okay, they look random enough. I'll start passing in the seed again, so I undid that change. Okay, great, we have 1 set of coordinates. We need a class that will hold 3 coordinates. So to hold 3 coordinates in one object, we will create a point class, and the point class will support an x, y, and a z value. So using NetBeans, I'm going to insert add a new class into our package. So I go over to the package for assignment 3, the subdirectory under source packages, I do new Java class. I'm going to call it point. Alright, all this one needs is 3 integers. Int x, y, z. I'm not going to initialize them to anything because Java initializes members of a class to 0. So 0 is a valid enough initial value for your points. However, maybe we could create a custom constructor, a parameterized constructor that would let us pass in 3 values when we create that point. Or we could just reference them, with set x, set y, and set z. So I'm going to add some getters and some setters to the point class. I'm just going to highlight the variables, the members that I want, and I'm going to choose refactor right click, refactor, encapsulate fields, and that will create some getters and some setters. There we go. Now we have get x, set x, get y, set y, get z, and set z. So to do that again, all I did is create a class called point. It had 3 members, x, y, and z. I wanted to encapsulate them, so I chose refactor, encapsulate fields. I want to select all because I want both getters and setters, and I do refactor. The comments are fine in this case, but we see that it turned the members private and our getters and setters are public. So going back to assignment 3, once we generated an x, y, and z, we would need to generate a point. Something like this, point p is equal to new point p dot set x is equal to x, p dot set y, we pass in a y, p dot set z, we pass in a z. Very good. Now that's just one point. We're going to want to create a bunch of points and add them to an array class. To an array list. We could create a for loop or a while loop, some kind of loop that would create as many points as we wanted. I'm going to set it to create 10 points. So how about a for loop? For int I, int will be our counter, is equal to 0, I is less than 10, I plus plus. Inside there we will create our point, and we will pass in set x, set y, set z. Why don't we print our values out? System.out.println. Creating %d, %d, %d. I'm using printf again. I'm going to go change that to a formatted printf so that I can use these placeholders. And we want to print out p.getx, p.gety, and p.getz. All right, this should print out 10 points. We run the application, and it is creating these same 3 numbers time after time. Why is that? I've made a mistake. My mistake was I created the point class inside the loop. I don't want to do that. No, that's not true. But I do create my random values outside the loop. I want to do all that inside the loop. So instead of doing x is equal to some value and then store it, and then y is equal to some value and then store it, and then z is equal to some value and then store it, why don't we just pass in the randomly number generated directly as a parameter to set x, y, and z? So rnd.nextInt with a maximum value of 8 plus 1 to make it 1 through 9. Again, rnd.nextInt 9 plus 1, and then R&D, yes, I should have just cut and pasted, 9 plus 1. Maybe space things out to make them prettier. All right. Now that saves some screen real estate. You know, the goal is not necessarily to cram as much text on the screen as we possibly can, but since we're making a video, I would like for you to be able to see as much code as possible. Now let's run it and see if we get 10 different objects that actually look random. If we look at them, 963, 946, 15, 9564, and so on, we see this 963 over and over and over because we are indeed seeding it with the value 1, 2, 3. If we gave it a different seed, then we get a different sequence of numbers. If we remove the seed, then we'd get a fairly random. There's no such thing as truly random in a language like this, but at least we get a different sequence of numbers every time we ran it. So that is our code for creating a point. And the next thing we're going to have to do is add this point to an array list. Once we get that array list built, we're going to have to run through the array list, putting the values into a map. And then lastly, we're going to want to print the map out. Now I have a problem here. This is not matching the specifications for the assignment. Why is that? Because the numbers for x and y were really supposed to be between 0 and 39, I believe. And 0 and 39. So how do I get 0 and 39? Well, since the random number generator goes from 0 to 1 less than the number specified there, I'm just going to put a 40 there. And a 40 there. Okay. And then this is a value of 1 to 9. I believe that matches the assignment. I have a syntax error because I did not close my parentheses correctly. All right. So if we ran this again, we should see some nice randomly generated points with the x and the y values set between 0 and 39, and the z value set to a number between 1 and 9. Now I'm not seeing that that worked. I'm going to clean it. It's running the wrong project again. Where's this enter value coming from? Oh, I think that's just from an old window I had left over. Okay, running it. Yep, the x coordinates look definitely like they're between 0 and 49 and 39. I'd like to see that change though. I'm going to remove the seed just so we can see the numbers change each time we run it. That's better. I like these numbers. Okay. I think I'm going to leave the seed out. So here's our code as it exists. If we're going to leave the seed out, we can delete that line. I'm going to pause this in case you want to type it in. And next we will add the array list. So an array list is used to hold a series of values. It's like an array, except it's open-ended. When you declare an array, you declare how many elements are in the array. In an array list, you can have 0 elements in the array, and then each time you call .add, then it'll add an element to the array. To the array list. So it's open-ended, it is not fixed length. So this does generate a new point each time we run through it, but we have not added it into a structure to save it. So each time it loops through again, we lose the last bit of data that we generated. So we need an array list. We need an array list of points. Let's instantiate one. So an array list of the point class, I'm just going to call it plist for point list, is equal to new array list. That is our syntax for creating an array list. What's it complaining about? We don't have the import for array list. I'm sure that I typed it correctly, so I'm going to go ahead and accept the choice that the error offers, that clicking on the error offers, which is add and import for java.util.arraylist. Now you don't want to be reckless about it, because what if I had made a mistake and I did not have the L capitalized? I came over here and I clicked on it and I just chose the top. Well, in this case, it's looking like it would work anyways. It would add and import for java.util.arraylist with a capital L. However, my code still here is broken because I put a lowercase l there. I'm going to undo all those changes. Now I have ArrayList spelled correctly, and I'm going to let it add java.util.arraylist to the imports. There we go. Now we have two imports going. We have java.util.arraylist and java.util.random. If we were going to use a scanner, we would add an import for that as well. So here's our point list. We have created it. We have instantiated it. We've declared, a new one. It doesn't have any items in it. As soon as we create our point, we will add it to our point list, our plist. So plist.add, and let's add our point to it. Now we're using some, some single letter variable names, which I don't really appreciate. I should call, this lowercase p here, I should do a rename and call it point or new point or something like that. But I'm going to leave it as is for now. I'm going to move this comment so that it's up above the add to p list. I'm going to add some more comments. Create the point object. And then fill the point object with random values. Maybe I can create a slightly better printf statement so it says creating point. Alright, very good. I can run it through now. And it created our points. I can scroll up and down. Yep, they still look random. Alright. This is great, but I really want this moved into its own method. And the reason for that is as I keep typing into the main class, it's going to be more and more difficult for you to see all the code on the screen at the same time. So I'm going to highlight the entire for loop from top to bottom, and I'm going to do refactor introduce method that will copy that code and place it into its own method. So refactor introduce method. I'm going to call it make plist, make point list. So now we have a method called makePointList, and that is used up in main. So this helps modularize our code. It reduces the length of the code that we're sticking in main. If we ever were going to move this code over to something else, then we already have it in a method that would make it easier to reuse. So I'm going to first leave this on screen. There's an extraneous comment down here, which I need to move up here. And I need to put a better comment above here. There is no comment. Create our array list of randomly generated points. And then run through the array list, putting the values into a map. Well, we're not there yet. But scrolling down, here's what the makePlist method looks like. See if I can minimize that so that we can get it all on one screen. Okay. Go ahead and pause, modify your code if need be to look something like this. You don't need the printf statement. I'm going to wind up removing it pretty soon. Now we want to iterate through our plist, our list of points, and we want to copy those values into a 2D array. The 2D array is going to be an array with an x and a y, and each element will be the z value of those points. So the points themselves have an x and a y component, which will be the two specifiers that specify the position of the element in the 2D array, and then the element itself will contain the z value of the point. So scrolling back up, here's our code. We create, we instantiate an array list of points. We call the makePlist method, which actually fills it with random values. Now we're going to go through the array list. To do this, I'm going to use a for each loop, or Java calls it a slightly specific, less handy term, but it's a for loop that will iterate through the plist without having to use an index value into it. So we don't have to declare, x is equal to 0, 1, 2, 3, 4, 5, and pull them out like that. But we could. So for each point in the plist, first let's confirm this is working. I'm going to take that print statement that we have down here in make plist, and I'm going to move it here so that as we're iterating through it, we can see that it's correct. All right, there's my print statement. I'm cutting that out because we don't need to be printing data as we generate it anymore. I'm going to come up and put that into the for loop inside of main. And instead of saying creating point, I'm just going to put point in plist. Give it a different title. That way we can see what it looks like. Why do we have errors here? Okay, there's a warning. It says can use functional operations. If you're using a new enough version of NetBeans in Java, there's something called functional operators. We don't really want to do that. If you click on that warning and let it fix it, it starts looking fairly ghastly. I don't want to do that, so I'm going to Control Z that, undo that. All right, so now we create a new array list. We call make plist, passing our plist to it, and now we're going to iterate through it point by point, printing them out. Make sure that it looks about the same as it has before. So I run the code. Here's the output. Let's expand it to see. Yep, each point in the plist, we have 10 items in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check your program assignment to see how many items you really were supposed to generate. All right, now we need a two-dimensional map, two-dimensional array to store these values in. And it's kind of cheesy just to do this, what I'm about to do. Int is equal to new, I didn't give it a name, is equal to new int 40, 40. All right. What's cheesy about it is that we have this number hard-coded here. That really ought to be defined as a constant higher up. But I'm going to run with it like this. I don't want to keep scrolling up and scrolling back down. So we have our map array. We declare our array here, and we allocate it here with our new command. So now we can specify values in the format of, the very first element in the top left corner of it looks like this. I could set that equal to a 9. Don't type this. And I could set the last one at 39, 39, to 100, 199, whatever. I'm getting a warning here. What is that? Oh, I lost my new statement. Is equal to new int 40, 40. And since it's declared out to 40, of course I can only iterate from 0 up to 1 less than 40. So that compiles. Well, we're not printing these values out, but that is how you address each element in a two-dimensional array. You give the row and then the column inside the brackets, and those match the dimensions of the array. So let's do that. I'm going to delete those print lines. Down here, underneath the print statement, I'm going to say map. Why don't we go ahead and extract those values? That's going to be kind of difficult to see if we don't do this. So I'm going to do int x is equal to p.getX. This is not strictly necessary, but I think it's going to make it easier to see. Int y is equal to p.getY. Int z is equal to p.getZ. I'm getting errors. Variable x is already defined. If I scroll up here, I see that I have x, y, and z defined. I'm going to delete that. Come back down here. All right. Now I can do map at position x, y is equal to z. That's why I did that, so I wouldn't have to put the p.getX here, the p.getY here, and the p.getZ here, although I could. All right, that fills up the map with the values from the array list. And again, I want to move this into its own method. First, I'm going to run it just to make sure that we don't have any compilation errors. And you can wait until the end of the code in order to move things to methods, but I like doing it before we do that. So I'm going to highlight all that code, choose refactor, introduce method. I'm going to call it make map or fill map. Make map's good enough. And so now I have a new method called make map. It accepts as a parameter the point list and a reference to the map array. It runs through the point list point by point with this for loop. Each point in the point list gets copied into the map using the x, y, and the z values for each point. So I'm going to leave this on screen to see if you need to double check your make map method. It looks like this. And appears right where we use it. So I'm going to scroll back up to the main method. Here's our main method. I'm going to add a comment here that this is end main. So one more thing we need to do. We filled up the map with randomly assigned values. We want to print it out. So printing a two-dimensional array is not a very difficult task. You can find code for it anywhere on the internet. We just need a nested for loop. For loop with rows and columns, or x and y. I think I'll use rows and columns. So, for each row in the map, let's change that a little bit. Int row is equal to 0. I'm just going to use a classic for loop, nothing fancy. While row is less than the length of the map, row plus plus. Now our inner loop will look similar. For every column is equal to 0, column is less than map. We have to get the length of the row though, so map at subscript row dot length, and then column plus plus. Now we have our nested loop. Let's print out the value at that position. So at map row comma column, that's our value. And once we get done printing an entire row, we want to print a new line. So system.out.println. So I run it. I see a bunch of zeros. I see a few values, like there's a 9 there, and there's a 5 there, a 9 there. We can look up there. Yeah. On row 1, column 36, there's a 5. Very good. In row 27, column 27, there's a 1. So way down here, there should be a 1. Yeah, that's probably it. Now we can make this a lot easier to see if we replace the zeros with periods or underscores or something like that. I want to do periods. So I'm going to change the code here just a little bit. I'm going to do this. String, and I'm going to call it spot because it's a spot on the map, is equal to the value at map row comma column. Now is that good enough? Is it going to do the conversion to be a string? No, it's not. So I will do that. I will add an empty string at the beginning of it. That forces a conversion of map row column to be a string. There are more elegant ways of doing that. That's a quick and dirty way of doing it. It's very commonly used, but it's kind of ugly. Anyways, that just turns spot into the number that is stored in that position. However, I want it to be a period if it's equal to 0. So I'm going to declare spot here, then I'm going to use an if statement. If map at row, comma, column is greater than 0, I want that spot equal to that, else I just want the spot equal to a period. And there are other ways we could do this. We could use a ternary operator down here. But again, this is a fairly simple way of doing it. Okay. And then we want to print out spot. So our logic is if the value of the map, of the coordinate at that map, is greater than 0, we set it equal to that number in a string called spot. Else, we set that spot equal to a period, and we print it out. I'm going to run it, make sure it works. All right, that's looking a lot better. Out here, our map looks like a 40 by 40 map. Looks like it has numbers through it. Looks like it has about 10 points in it. You know, if it overrode any points, it could have slightly fewer than 10. But 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Yep, it has 10 points. So that is just about a finished assignment. But as I've been doing with the other ones, I want to move this into its own method. The reason I'm going to do that is it's going to make the main method extremely clean to look at. And this is going to be an extremely modularized piece of code. So I'm going to right click after highlighting all that code, do refactor, introduce method. I'm going to call this print map. It has created a method called print map with this code in it. I'll stop talking for a moment. You can pause it if you want to eyeball it. Then, up here, we see where it calls print map. So if we didn't have this comment here, take a look at what the main method looks like. These are without the comments. I'm going to undo that change. But you can see we make a random number generator. Maybe I will leave it like this. I'm going to rearrange the order just a little bit because I want all my declarations up at the top. So where we create the map, I'm going to move that up here to above the make plist method. So I'm going to add some comments. Create our objects. And then down here, let's add another comment. Generate random map. Generate random points in a list. The next one's going to be copy values from list into 2D map. And then lastly, print map. Now since we moved that code into its own method, I'm going to run it, double check it, make sure it works. Looks about the same as it did before. So improvements would be, these are hard-coded numbers. These are magic numbers. They really should be a constant. Another hard-coded number is way down here where we generate a value between 1 and 10. 1 and 9. But that is just so that the number would fit comfortably within a single cell, within a single character on the screen. And then here we generate 10 numbers, whereas that should also be a constant of some kind, either a parameter that's passed in or whatever. So if your assignment is to generate 40 points or 20 points, I forget which it is, you're going to want to change that inside your make plist. If you want to move everything to a constant, you can do so. You can move them up here. Why don't we do that? Just for complete thoroughness sake. I'm going to declare some constants. Static int max map rows equals 40. Static int max map columns equals 40. Static int number of points equals 10. And then I'm going to go use those values. Over here where we generate our map, our two-dimensional array, I'm going to change that to max map rows. And I'm going to change this one to max map calls. And then down inside our random number generator function, where we generate 10 values inside make plist, we're instead going to use that constant. So for I is equal to 0, I is less than num points. Okay, let's go look at the main method one more time. Here's our main method. We create our objects, a random number generator, a plist, which is an array list of points, and then a two-dimensional array called map. We have our constants defined up here. I guess they're not really constant until we add the word final to them. Not strictly necessary, but now we can officially call them constants. Then we call our method that generates the random points and adds them to the list. We call another method called makeMap, which copies the values from the list into a 2D map, and then we print that map out. So I'm going to leave this on the screen just for a moment, and I'm going to scroll down so that we can look at each method in turn, and we will be done. Go ahead and export this to a zip and turn it in, submit it. That's an extraneous comment. End method, make plist, and end class. So that's our make plist method. All right, hope that helps.